The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours, but that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
It's becoming colder by the minute. The temperature drops below zero very quickly. And although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky, and their jaws drop in disbelief. The sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the Sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, there are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the Sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the Sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the Sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the Sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the Sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the Sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the star seeming more like a giant, pitiless blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high, those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies. All of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides with the current tilt and rotation, like you would roast a barbecue. It turns to the sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?
In space, no one can hear you scream. Or is that, in space, no one can hear ice cream? Well, either way, we know that no supernovas, crashing asteroids, and burning planets make a sound in space. Or do they? What if you actually can hear something out there? Well, let's see. Okie dokie, back to middle school. Sound is a mechanical wave originating from vibration. What exactly does that mean? Well, the simplest example is guitar strings. Let's pluck one of them. It starts to vibrate. The atoms inside the metal string begin to push and beat the atoms of the air around them. So now, atoms are constantly pushing each other until they reach our ears. It's like a wave from a pebble thrown into a pond, and it happens very quickly, at a speed of about 761 miles per hour. Then our eardrums begin to vibrate at the same frequency, and the little bones inside our ears transmit this vibration to the brain. The brain then does its magic, recognizes the pattern, and turns it into sounds. Great! Now we know that we need some particles to create sound, and we can find these particles in gases, liquids, and solid substances. And what about space? Nope, it's almost a perfect vacuum. And you've probably already heard that there's no sound in space because it's a vacuum. But what does it actually mean? Well, a vacuum is a perfect void. It's an area completely devoid of matter. It means there's nothing there. Yeah, despite all those celestial bodies in space, there's actually no air in between them. No atoms, no particles, nothing, nada, zippo. Well, almost. To be honest, the perfect vacuum doesn't really exist. We can't get rid of atoms for good. But space is very close to this notion. On average, there are 15 to 80 atoms per 1 cubic inch. This may sound like a big number, but keep in mind that these atoms are tiny, and the void distance between them is huge. For comparison, 1 cubic inch of air contains about 16,000 atoms. So, of course, with such a low density, these atoms can't push each other. Even if the vibration is very strong, like, I don't know, a supernova, they still won't be able to do that. So, movies have been lying to us. All these epic space scenes actually take place in an awkward silence. Who would have guessed? But don't get upset. What if I tell you there are, in fact, some ways to hear sound in space? First of all, there's still sound on other planets. If there's an atmosphere on a space body, or at least something like gas, water, or a solid surface, there will be sound. In our case, the atmosphere becomes completely silent at about 60 miles above the Earth's surface. That's where the sky stops being blue and a black starry veil begins. In any case, we'd have to land on another planet, or at least get close to its atmosphere to hear something. But whatever it is, it would sound very different. Let's take our favorite Venus as an example. The atmosphere there is very dense. Scientists jokingly call it a thick chemical soup. No thanks. So, if you somehow managed to stay alive and speak there, your voice would be very different. It would become much louder and it would sound deeper. So, if you want a pleasant baritone, you know what to do. I wonder what would happen if Earth had a denser atmosphere. What would we hear then? Well, you can vaguely imagine that if you've ever been in the water. Water is very dense. Sound moves there much faster and better compared to the air, at a speed of almost a mile per second, depending on the water temperature. So if you sit in an empty room with no sound sources, you won't hear much, right? Now, dip your head in the water and check out how the same silence sounds here. It's not quiet at all. Even if you ignore the ever-present sounds of the water itself, you'll immediately notice how well you can hear your own body, how your blood pulsates in the veins, how your heart works, the slightest movement of your fingers. Kinda creepy, isn't it? This gives us an idea of what would happen to us on a planet with a denser atmosphere. And that's just crazy. We would hear everything. From scurrying animals to the movement of tectonic plates. Come on, you'd probably say. It's obvious that there's sound on other planets. But didn't you say we can hear something in open space? Actually, yes. For example, in a cloud of dust. You can find space dust almost everywhere in space. It may be the remains of a star or something else. And in these places, everything is a bit denser than usual. This means there are probably dust clouds where particles are very close to each other, which means they can produce sounds. Of course, those will be very quiet and transmitted over a very short distance. But it's better than nothing, right? Plus, we already have one real space sound recorded. It came from the Perseus galaxy, which is located 250 million light-years away from us. NASA recorded it in 2003. Those of us music geeks will want to know that it's a B-flat, 57 octaves below middle C on the piano. You'd have to add another 660 keys to the left on the keyboard. But its frequency is so low that the human ear unfortunately can't hear it. But besides that, we can only hear something inside spaceships. These are small pockets of air, after all. In a spacesuit, you would hear sounds very well, too, including your breathing or blood circulation in a spacesuit. But two astronauts flying side by side wouldn't hear each other, even if they got very close and shouted very loudly. It's quite funny. If you, being an astronaut, bumped into something, it would be very loud for you, but your friend wouldn't hear anything. That's why astronauts use radio devices.
2091, cancel your call, 2879 will handle.
Now, purely theoretically, if you could somehow crawl out of your spacesuit and survive, you'd be able to hear the chatter and noises going on inside the spaceship. But how? So look, we have some air inside the spaceship and it transmits sound. It reaches the metal casing and gets through it. And then, if you leaned against the ship, preferably touching it with your elbow or knee, the sound would be transmitted to the brain directly through your bones, ignoring the ears. Yes, our bones conduct sound. That's how, for example, deaf people listen to music. It's called bone conduction. It's used in some headphones and some other technologies. You can do a little experiment. Hold your fingers over your ears. Shut them properly so that you really don't hear much. Then try to touch a sound source. It can be anything vibrating. For example, a speaker playing music with some part of your body where the bone is close to the skin. Now, watch the miracle happen. You can hear the sound not through your ears, but directly in your brain. But please, don't repeat this experiment in open space. Ice cream? Now, you've probably heard about things like the sounds of space, where you can listen, for example, to the sounds made by the sun or different planets. How do we record these ones? Easily. There is another way to hear sound in space: electromagnetic waves. In other words, a radio. Radio is the same form of electromagnetic radiation as light. These waves can travel in a vacuum without any problems. Astronauts' transmitters work that way. An astronaut says something to their friend. The sound waves turn into radio waves, reach the other person, and are then converted back into sounds. And this is how we get so-called space sounds. Our planet is actually very loud in that regard. We're sending a huge amount of radio waves into the universe, all radio signals we've ever listened to. It's a pity that they travel only 110 light-years away from us. But I think it's good that we don't hear everything that happens in space. Imagine if sound could easily travel through the universe. We would hear everything, from solar flares to nearby supernovas. Horrifying, right? So maybe we're just lucky. Hey, remember, in space, you can hear ice cream. Chocolate! Vanilla! That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.